All right, so we have chapter 2, problem number 67. A car starts from rest at a stop sign. It accelerates at 2 meters per second squared for 6 seconds, coasts for 2 seconds, and then slows down at a rate of 1.5 meters per second squared for the next stop sign. How far apart are the stop signs? So in this problem, they've given us a lot of information. They've got a lot of stuff to look at, and work with. So what I've done is I've broken it up into 3 sections. You see that I have my initial information, or my section 1 information. I've got my section 2 where we're coasting, and then I've got my section here where we're then slowing down, coming to the next stop sign. So if we drew this out, our first section would start as we go from here to here. Right? Our next section that we'd be looking at, right, the section 2 would go from here where we have a constant velocity, meaning our acceleration then is 0, and then we would have our final section as we get to the last stop sign as we get there. If I just label them for you, like so, and there we go. All right, so we're going to break these up into individual sections, and then that'll allow us to find the final distance that is between each of the stoplights. All right, so for section 1, if I look at what I know the initial speed is 0, I know that the initial acceleration is 2, and the time is 6. All right, so if I want to find out how far I'm going to travel in that instance, I'm going to use the kinematic equation of x equals x sub o plus v sub o t plus 1/2 a t squared. All right, now the x sub o is our initial position, and if we're taking the first stoplight, or the stop sign, to be where we're starting from, then our initial position is 0. We're starting from rest, so v sub o is 0, and doesn't matter then what the time is. Right, and then we have 1/2, and we know that we're going to accelerate at 2 meters per second squared, and we're going to do that for 6 seconds. So that'll be our 6 squared. And when we put all of that together, we find that for this 6-second segment, when we're accelerating at 2 meters per second squared, we're going to travel a distance of 36 meters. The second section is where we'll be traveling at a constant velocity. All right, we will not be accelerating. So if we're going to find out how far we're going to be traveling, we need to know how fast we're going to be traveling in that segment. So for that, to find that speed, I'm going to begin with the equation of v sub f equals v sub o plus at. Right, now this is all going to be information from the first segment, but once we find that speed, when we're at the end of that segment, that speed will then carry on through section 2. So that's why we're doing what we're doing here. So we've got the initial speed of 0, we've got the acceleration of 6 for a time of, the time of 6 with the acceleration of 2. So then at the end of section 1, we should be traveling at 12 meters per second. And using that information, we'll be able to determine how far we travel. Because we're traveling at a constant speed of 12 meters per second, we can use v equals d over t, where v is 12. Now this segment in which we'll be traveling at a constant speed is for 2 seconds. So solving for d, we find that for the second segment, we travel for 24 meters. And you can see I'm kind of flipping between x and d. It's kind of just a habit, probably a bad habit that I learned as growing up, but it is what it is. So for section 3 now, we want to know, we're going to be slowing down, and we want to find out how far we're going to travel there. So we know the initial speed when we start that segment is going to be 12 meters per second. And we know when we get to the end of segment 3 or section 3, we're going to be at 0 meters per second. Because we know these two speeds, and we know what the acceleration is going to be, and we know nothing about time, then the kinematic equation of v sub f squared minus v sub o squared equals 2ad is perfect for us. So we're coming to a stop, so v sub f is 0. We started section 3 at 12 meters per second squared, and we're going to put that 2, and then we have a negative acceleration of 1.5 meters per second squared, and we need to solve for D. Doing that workout, solving for D, we find that it is 48 meters for section 3. So the last thing we have to do if we're going to find out what it is we're traveling or how far we travel from stoplight to stoplight, stop sign to stop sign, right, is X total is going to be equal to 36 plus 24 plus 48 for a total of 108 meters. This is a pretty good problem because it forces you to use really all the kinematic equations, and you can see where they're applicable and where you need to use them. So there you go. That's chapter 2, number 67.